Thank you very much for a very generous introduction. I'm tempted just to sit down, because it could only go downhill from here. It's a great honor to give these lectures, and I looked at the list of speakers in the past. Freeman Dyson talked about life in the universe, and so I would not want to compete with Freeman, and so I will stay away from life in the universe. But I will mention Fred Hoyle, who was also a lecturer. And so my topic is cosmology, and I've organized it by kind of a get going and telling you that the universe is not so scary, it's pretty simple. And then we segue into the interesting universe, where we talk about the big puzzles and these deep connections between the very big and the very small. And then the last lecture, and I'm benefiting greatly from staying at the Colonnade Club, because the Colonnade Club has scholars from around the world. And so if you go down to the lounge, you can encounter someone who asks you why you're here and what you're going to talk about, and then they give you advice on this last lecture, which is the hard one, the future and limits to cosmological knowledge from Earth. Anyway, so, and hopefully you'll help me finish that lecture. So the first two I'm quite comfortable with. The last one I think will be the most fun, and so I hope you stay around for that one, but I'm still working on it. Okay, so first of all, what is cosmology? And were we going to lower the lights just a little bit at some point? Okay, someone will figure that out. I want you to be able to see all the pretty pictures, or maybe I have to do that, but I think the lights will go down at some point. So what is cosmology? So cosmology deals with the really, really big questions. Can you see better?
Yes.
Now, are you worried about your neighbor stealing your wallet? I guess this is Chicago. So in Chicago, that could be a problem. So I'm a really big picture guy. I don't fly lower than 100,000 feet. So how did the universe begin? How did we get here? How will the universe end? Are we alone? The really, really big questions. So what's wonderful about cosmology is these are questions that mankind or humankind has been asking, I guess first mankind and then humankind, forever, and everyone can understand them. That they all have appeal. Cosmology, as I was telling someone I was talking to last night, really sets the context for human existence. Okay, so will the defense stipulate that cosmology is interesting? Okay, good. On the other hand, progress in cosmology, what did I put here, is uneven. I like to call it boom or bust science. And so I'm going to try to convince you we're in a big period of discovery. So why is it so hard to explore the universe? It's because the universe is very big. And so if you're ever asked a question about the universe, the answer is billions. That's a safe starting point. And so the universe is often beyond the reach, both our instruments and our ideas. And so that's going to be a big theme here, is it takes not only instruments to explore the universe, but also ideas. And so the way I like to think about it is that I say just beyond the reach. So, we're not quite there, and then an improvement in instrumentation or a key idea launches a big period of activity. And so we are in, I believe, one of those periods right now. My colleagues accuse me of wandering around the hall saying cosmology is in a golden age. And, I don't know if that's true, and then also I learned that golden ages are not always that good, because then after the golden age, anyway, so I deleted the part about the golden age. But so we're in a period of revolutionary advances, and driven, I want to get this idea across, not only powerful instruments, but powerful ideas. So how did we get here? So I'm going to slowly, introduce you to the universe and what we know about it. And we'll start out with the universe that's easy to understand, and then we'll get to the more complicated things. So here's Galileo. I knew him well. He's my thesis advisor. Not quite true, but so if I'm not mistaken, in some ways we call him the father of science. Now I know Plato and Aristotle are in there, but he actually decided that you should build instruments to extend your knowledge. And interestingly enough, 400 years ago, Galileo took an instrument that somebody else built and turned it to the sky, a telescope. And that instrument was also a microscope, and it was turned to look at the subatomic world. And it's fascinating that my theme next time will be that these two journeys, very, very journeys that involve massive instruments now are coming together. But here's a number, and again, you know, all the numbers, so if you're not taking notes, just remember a billion. But the increase in sensitivity of our instruments on the sky since the time of Galileo is about 100 billion. And for the physics students or the astronomy students, you know, try to figure out how I got that number. And, you know, it's kind of like a political campaign. There's some gimmicks and, you know, short selling some, you know, university property to make everything work. And, okay, so let me just give you that montage. 100 years ago, the time scale, I apologize for this, in cosmology, a lot has happened in the last 100 years. In fact, I'm tempted, if I didn't think there were people from other disciplines, I would be tempted to say most of cosmology has happened in the last 100 years because our instruments have become good enough. But 100 years ago, the observatory run by the University of Chicago, Yerkes Observatory, had the largest telescope, and it was a 40-inch telescope, and everyone in this room would have known how to use it. Because it's, you know, one of those look-through telescopes where you stand here and look there. And, of course, Yerkes Observatory, for those of you who are know, I mean, it's in the Midwest, on a lake. It's not the best seeing conditions. And actually, George Ellery Hale was the person who got the money from the robber baron Yerkes, who needed to get his name rehabilitated. He's the guy who built the L trains in Chicago. And he then went on, after building this observatory, he then went on three more times, so 4 times total, to build the largest telescope. And so on Mount Wilson in California, he was visionary enough to realize that the future of astronomy, you got to get to higher sites where there's less atmosphere. And so he built a 60-inch and a 100-inch telescope. The University of Chicago could have had these observatories. He spoke with the president of the University of Chicago and told him that the future of astronomy was in the hills of California, on the mountaintops, and William Rainey Harper wished him well. And so here is the 100-inch that Hubble used to make his big discoveries that I'll tell you about shortly. And this is of a new style of telescope that actually was pioneered at Yerkes Observatory. So instead of a lens, it has a mirror down here. And so actually this kind of telescope, you wouldn't quite know where to sit, but the light comes in, it hits a mirror, and it's reflected to various other mirrors, and sometimes you sit up here in the prime focus cage. And this telescope, the 100-inch, was donated by a very civic-minded group of women in Pasadena, and it's known as the Hooker Telescope. Well, that's one story I heard. There may be other versions of it. So this is the 100-inch, and we'll be talking about that. The telescope that really sort of captured the entire country, sometimes known as the giant eye on the sky, was the 200-inch telescope at Mount Palomar. That took almost 30 years to build, 25 years to build. And here, there's the mirror. This is the dome. So this is, the dome is quite large, and the mirror is 200 inches. That's a ladder, and there's a person there. And the prime focus cage, I think, is about 60 or 70 feet above the mirror. And I had the privilege, the fun. Let's not use I had the fun of being able to be in that prime focus case. Even though, let's see, I should have introduced myself. So I'm not an astronomer, I'm a hand waver. So I'm one of the theorists. So there'll be a lot of jokes about, you know, the experimenters being the plumbers and a little slow on the uptake. Yeah, see, you heard them laugh. It takes them a while to get the jokes. So this is the 200-inch in California. And I couldn't resist showing these pictures. So in the olden days, astronomers would go to the mountains, and it was a very romantic experience. And they would stay in some lodging on the mountains that both at Mount Wilson and Mount Palomar, for whatever reason, were called the monasteries. And astronomy is really romantic. I've never stayed in the Mount Wilson Monastery, but I did stay in the monastery at Mount Palomar. And it's very cool to be up there. And you're detached from the rest of the world, and you know, you sit in that prime focus cage, and it's you and the universe. And of course now, the biggest telescopes, many of the biggest telescopes are on top of Mauna Kea. The two Keck telescopes, 400 inches, and then there are other telescopes, Japanese and American telescopes, really big telescopes. So that's one of the best sites in the world, even better than California. And then the Europeans, of course, we can't give it in inches, we have to give it in meters, have 4 8.5 meter telescopes. You know, this is, I guess I didn't take this photograph because if you go to the top of this mountain, Paranal, in Chile, you can't, they've got so much telescope up there, an ordinary camera can't photograph them all at once. And so this might be what Ornstein Veblen would call conspicuous consumption. But we still do better science than Europeans. And then another part of this story, which has a connection here with NRAO, is that we have more eyes on the sky, not just optical eyes, but radio, X-ray, gamma ray, microwave. And this, I hope, is Carl Jansky. Is that right, Ken? Who built one of the first radio telescopes, so it's very strange looking, and discovered radio emissions from the sky. And the first real radio astronomer, it's going to be a lot of stuff about Illinois here, Grote Reber, who from his home in Wheaton, Illinois, took this discovery by Jansky and actually did astronomy and published papers in the Astronomical Journal. And this is in his backyard.